Okay. Hi everyone. Today we are going to learn about some another kind of defects which is called as an imperative defect. Okay. So in part one, we have already learned about a vacancy defect and interstitial defect. But today we are going to learn about an imperative defect. Okay. So what is an imperative defect? Now, any kind of substance when it is added with another compound or an element or the mixture, it is known as an impurity. Okay, so any substance which is in a pure state, when I am adding any compound, so it is known as an impurity. Okay, so here an example is given of if the molten NaCl, NaCl means a salt, common salt. Okay, so if molten NaCl containing a little amount of SrCl2, strontium dichloride, is crystallized, some of the sides of Na plus are occupied by a Sr plus 2. Okay, means Na plus Na plus. Now Sr has a plus 2 charge. So when there are the two Na are displaced, there will be only a one Sr plus 2 will be get stuck into the atom to balance the electrical neutrality. So two Na plus, two sides are becoming vacant and only one side is filled up by strontium. So there is one vacant side, but electrical neutrality is there. So this kind of defect, it is known as an imperative defect. Okay, so it occupies the side of one ion and other side remains vacant. So the cationic vacancy produced are equal to the number of the Sr plus 2. Another similar example is when a solid solution of cadmium dichloride and AgCl. So cadmium is also having a plus 2 charge and Ag has plus 1. So when two Ag are removed, only one Cd is required to fulfill that electrical neutrality. So how much how much atom of Cd are placed, that much will be the vacancy defect. So if I am putting 5 Cd, there will be a 5 vacant places in my atoms. Okay. Now the another type of defect is non-stoichiometric defect. Now the difference between the stoichiometric defect and a non-stoichiometric defect is stoichiometric defect is a uniform defect, means 1 centimeter has one defect, that another 1 centimeter is also having only one defect. But non-stoichiometric defect is a defect, means if 1 centimeter has 5 defects and another 1 centimeter has only 2 defects. So this is not uniform defect, and this kind of defect it is called as a non-stoichiometric defect. Okay, so the defect discussed so far do not disturb the stoichiometry of the crystalline substance. However, a large number of non-stoichiometric inorganic solids are known which contains a constituent elements in a non-stoichiometric ratio due to the defect in their crystal structures. So these defects are also having the types. First type is metal excess defect, means if there is a compound in which metal is more as compared to non-metal or any kind of another substance or the atom. So it is known as a metal excess defect. And another is metal deficiency defect, means a compound है कि जिसमें metal and something with metal oxide है. So कोई बार ऐसा होता है कि metal ज्यादा होता है, is metal is in a higher proportion as a actual stoichiometric ratio. So it is called as metal excess defect. While in another type is metal deficiency defect, means we are talking about a FeO. So हमारा फॉर्मूला के हिसाब से Fe एक एटम होना चाहिए and O भी एक एटम होना चाहिए, but in reality FeO is never Fe1 and O1. It is always Fe 0.93 to 0.96 on an average. कोई बार 0.93 होता है, कोई बार 0.96 होता है, according to the ore from which place we have taken. Okay, so it is known as a deficiency or metal deficiency defect, we can say. So now metal excess defect. So metal excess defect due to the anionic vacancy, means if the anionic vacancies are created, so it is known as a metal excess defect. Now alkali halides, means alkali halides are NaCl and KCl. So this type of defect when crystals of NaCl are heated in atmosphere, means जब मैं common salt होता है उसको मैं heat करता हूँ, क्या होगा? So the sodium heated in an atmosphere of sodium vapor, means sodium vapor में heat करता हो, तो अब according to the law sodium heater है, sodium का more concentration है, तो NaCl crystal gets stuck with a sodium vapor atom. So now it is known that NaCl था, and if Na एक और बढ़ जाएगा तो NaCl क्रिस्टल है, and एक और बाहर Na आ गया, so Na is in a free state. तो क्या होगा कि Na is a more having a more energy according to the temperature difference. Okay, तो क्या होगा कि the combined Cl of NaCl crystal will be losing that pair, and it is now connecting to the Na which is recently stuck to the crystal. तो क्या होगा, अंदर एक F center चला जाएगा. F center means a vacancy created due to the breaking of a bond between a original NaCl crystal and forming a bond with a new Na plus ion. Okay, so this happens by a loss of an electron by a sodium atom to form a Na plus. The released electron diffuses in a crystal and occupies anionic side. मतलब पहले Na था तो वो Na plus बन जाएगा. So अब क्या होगा, Na plus ऐसे ही तो नहीं बनेगा, इलेक्ट्रॉन लूज करना पड़ेगा, and this electron will be present in an then atom, then it is known as an anionic side. So as a result, the crystal now has an excess of sodium. मतलब जो पहले एक सोडियम एंड एक क्लोराइड होना चाहिए था, अब दो सोडियम एंड एक क्लोराइड है. So the anionic side occupied by unpaired electrons are called as a F centers. From the German word Farbcenter for a color center, means जो F centers होते हैं ना, they are only responsible for the color of the crystal. ओके मतलब NaCl को सोडियम वेपर में हीट करता हूं. नाउ Na इज समवॉट येलोइश इन कलर. सो मेटल जब सोडियम एक्सेस हो जाता है ना सॉल्ट में, तो वो व्हाइट की जगह पर येलो सॉल्ट हो जाएगा. ठीक है, सो दे इम्पार्ट येलो कलर टू द क्रिस्टल्स ऑफ NaCl. द कलर results by the excitation of this electron when they absorb energy from the visible light falling on the crystal. Means अब देखो सॉल्ट है, उसको लाइट में रखूंगा, light में if it is placed then it will be absorb some energy and impart a color. So NaCl having a excess sodium, it will be having a yellowish color. Okay, so the color result by the excitation of the electron absorbs the energy from a visible falling on the crystal. Similarly, excess of lithium makes LiCl crystal pink because lithium color is pink, so excess of lithium will imparting a pink color, and excess of potassium chloride having of excess potassium will be impart a violet color, or we can say a purple color, because violet has a so potassium has a violet color. Okay, so if any doubt then ask me. Fine. The last type is metal excess defect due to the presence of extra cations and interstitial site. So zinc oxide, everyone has seen a zinc oxide stone or a powder. So zinc oxide is in a white in color, but at a room temperature. Okay, at a room temperature only, but on heating it loses oxygen. Means zinc oxide है, उसको मैं heat कर रहा हूँ, क्या होगा, ऑक्सीजन है, ऑक्सीजन तो फ्री स्टेट में चला जाएगा, and that will be only remain as a zinc. So it will be, the reaction will be ZnO on heating, it will be only Zn plus 2 plus half O2, means half mole O2 मिलेगा, but मिल जाएगा O2 हमें, and 2 electron liberate हो जाएंगे. Now there is an excess of zinc in the crystal and formula becomes Zn1 plus XO. The excess Zn plus ion move the interstitial side and the electron to the neighboring interstitial side. मतलब ये जो excess आपका zinc बच रहा है वो क्या करेगा, अब दूसरा तो ZnO है, एक ही एटम को हिट किया, मतलब जो तुम्हारा एटम होगा ना दूसरा ZnO, उसमें क्या होगा, Zn1 plus X हो जाएगा. ठीक है, तो रिमेंबर इट इज आस्क्ड इन एमसीक्यूज एज द ऑब्जेक्टिव दैट गिव द फॉर्मूला फॉर मेटल एक्सेस डिफेक्ट ऑफ जिंक ऑक्साइड. So answer will be Zn1 plus X and O. And the another MCQ is which center or which element will provide a color to the metal excess defect. So answer will be F centers. F centers की वजह से ही हमें कलर मिलता है कोई भी क्रिस्टल का. ठीक है, now the third is metal deficiency defect. अब metal deficiency मतलब क्या, जो हमने ऊपर के टॉपिक्स देखा उसमें मेटल का कॉन्सेंट्रेशन हमारा जो स्टोइकियोमेट्रिक रेशियो है उससे ज्यादा है, बट अब क्या होगा कि स्टोइकियोमेट्रिक रेशियो से कम होता है जो मेटल, उसमें बोलते हैं मेटल डेफिशिएंसी डिफेक्ट. तो आई हैव टेल यू अर्लियर दैट मेटल, सो Fe के कितने आयंस होते हैं पता है किसी को? Yeah, so Fe has two states, two ionic states. First is Fe plus 2 and another is Fe plus 3. But जब हम लोग एफईओ की बात करते हैं तो एफईओ में तो +2 ओ ही चाहिए। तो ऐसा तो नहीं होगा ना कि मैं दिल्ली का कोई और ले रहा हूं तो उसमें Fe+2 के ही सब आयंस होंगे, Fe+3 होगा ही नहीं। ऐसा नहीं होता। जहां Fe है, आयरन है, उसमें थोड़े पार्टिकल्स Fe+3 भी प्रोड्यूस करेंगे, थोड़े पार्टिकल Fe+2 भी प्रोड्यूस करेंगे। ओके, सो देयर आर मैनी सॉलिड्स व्हिच आर डिफिकल्ट टू प्रिपेयर in a stoichiometric composition and contain less amount of metal as compared to stoichiometric proportion. A typical example of this is FeO. Okay, so which is mostly found in a composition of Fe.95O. So इधर 1 के जगह पर 0.05 मेटल कम मिल रहा है. So it is due. So it is may actually range from Fe.93O to Fe.96O. So in crystal of Fe, some Fe+2 cations, मतलब जो Fe+2 जहां पर होने चाहिए वो कौन रिप्लेस कर रहा है, तो कि Fe+3 रिप्लेस कर देगा। बिकॉज हमको रिक्वायरमेंट 2 का है बट हमको कोई एटम 3 दे देगा, उसका मतलब कि हमारा तो रिक्वायरमेंट कम हो जाएगा ना। So in crystals of FeO, Fe+2 cations are missing and the loss of a positive charge is made up by the presence of required number of Fe+3। मतलब जहां पर Fe+2 कम है वहां उसकी जगह कौन फिल कर देगा, क्योंकि Fe+3। So that's why this is called as a metal deficiency defect। Okay, so today we have learned about a metal deficiency defect, metal excess defect, and non-stoichiometric. These all are non-stoichiometric defect. Okay, so if you have any doubts, then you can tell me in a comment box also. Okay, and if you want to get a fair idea of any of the topics related to chemistry, chapter number, any chapter, so you can comment me in a comment box, and you can subscribe our channel for future updates for a chemical aspects or for English or mathematical aspects. Okay, any doubts? Bye bye.